Let's solve the inequality and graph the solution set on a real number line. We have x squared minus x minus 12 is less than 0. Now, if we look at the function f of x equals x squared minus x minus 12, and we were to graph that, it would represent a parabola or a quadratic function. And what we're really looking for when we solve this inequality is when the picture of this graph would fall below the x-axis, since we want to know when this is less than 0. So the first step we do is we solve the quadratic equation, x squared minus x minus 12 is equal to 0. This is going to give us our boundary points. This factors x minus 4 times x plus 3 is equal to 0. If we set each factor equal to 0, we get two solutions. X is equal to 4 or x is equal to negative 3. Now, let's move on to step 2. In step 2, we put our boundary points on a number line, negative 3 and 4. Notice on our number line we have three different intervals. We have the interval to the left of negative 3, we have the interval between negative 3 and 4, and then the interval to the right of 4. So in step 3, we want to choose a test value in each of the three different intervals in order to see whether it provides a true or a false statement, or whether it's positive or negative. Let's choose a value to the left of negative 3. Let's say let x equal negative 4. Let's actually substitute it into the quadratic function. If we substitute negative 4 in, we get negative 4 squared minus negative 4 minus 12, which gives us 16 plus 4 minus 12, which is certainly a positive number. It's 8, so it's positive here. That means if we were to graph this function, it would lie above the x-axis in this interval. Let's choose a value between negative 3 and 4. Let's let x equal 0 and find the function value. We'd get 0 squared minus 0 minus 12. This would give us a value negative 12, which is clearly a negative number. And let's choose a value to the right of 4. Say x equals 5. If we substitute this into our quadratic equation, we have 5 squared minus 5 minus 12, which gives us 25 minus 5 minus 12, which gives us a value of 8. So that's positive. Now we can see the intervals where this function is positive and the interval where it's negative. Now, in order to write our solution, we need to look at what the original problem was asking. We want to know when this function is less than 0, or in other words, when is it negative? Well, clearly it's negative in the interval here between negative 3 and positive 4. So the graph is an open interval between negative 3 and 4, since it does not include the endpoints negative 3 or 4. The solution set is the set of all x such that negative 3 is less than x, which is less than 4. And finally, the interval notation we can always take directly from the graph. It's just the interval from negative 3 to 4.